we assume type is integer. Okay, now this is a concrete type. Okay, so it's not a template. Now we are using the template now with a concrete type. Okay, so when you define your pointer P, it will be a pointer that points to a node of type integer. Okay, so it means that the info stored in the node is an integer. Okay, now you substitute type by a concrete data type. Okay, that you use in your application. Now, if you are dealing with a linked list of student record, then you have node of student record. Okay, so it can be any primitive type, or it can be any user-defined data type. Okay? Now, if you are, say, originally having a linked list, okay, like this, okay, then you want to insert a new node in front of the first node. Okay, now head is a variable that is pointing to the first node in the linked list. Okay. Now to add a new node at the front of the linked list, first of all, you need to create the node. Okay. Now after you create the node, you put the value x into the info field of the node that you have created. Okay. Now after that, you need to set up the length. Okay. So you want to put the node P at the front of your linked list. Then you will set the pointer length of P to point to the node head. Now you set up this pointer in step 1. Okay. Now after that, after the insertion, the first node in the linked list is now the node X. So the value of head will be modified, not to pointing to the node number 45, but now it should be points to the node P. Okay? So head will be changed to a new value P. Now head is now pointing to this node, to the new node. Then you have a new structure of the linked list. So if initially the linked list is empty, then it means that if the linked list is empty, then it means that head has the value null pointer. Okay. So after the first insertion, now you have a linked list with one node. So if initially, okay, head is the null pointer. Okay, then you create, okay, the node P with the value x, and now the length of P is equals to null. Okay, equals to head. And it means that it is assigned the null pointer. Now this is length of P, assign the value of head. Okay? Because head is null pointer. Now the length of node P is set to the null pointer. And the next step is head is assigned the value of P. Now, after the insertion, head is pointing to the node P. Okay, so after this step, now you have a linked list of one node. If you do another insertion at the front, okay, then you have a linked list with two nodes. Okay, so if you repeat that insert operations, then you build up a linked list with multiple nodes. So every time you add a node to the linked list, you need to create the node using the new operator. Meaning that you ask the operating system to give you memory space for storing the node structure. Okay, after that you put your values into that node structure. Okay, so is this answer your questions? If you start with nothing, then you build up a linked list with something. Okay. Now to remove an element, okay, from the linked list. Okay. Now suppose you want to remove the element by value. Okay, so we specify a value and we want to do some removal. Okay. Now suppose this is our current linked list. And assume we want to remove the value 34 from the linked list. Okay. Now, in the current structure of the linked list, we call this a single link. Okay. Meaning that every node we only have one pointer that points to the successor. Okay, so it is single pointer. Now, if you want to take out something from the linked list, remove it, you need to know the predecessor of the node that you try to remove. Okay? If you don't know the predecessor, then you cannot modify the link to maintain the structure of the linked list. Okay, now conceptually, if you want to remove 34, then after the removal, you expect to come up with a linked list with this structure. Now 34 is no longer in your linked list. Okay, so you want to obtain this structure. Okay. Now in order to be able to do the removal, now you want to take away this one. You need to know the predecessor. Okay, the previous node of the node that you try to remove. Now, when we traverse the linked list to perform a delete operation, we will need to use two pointer variables. Okay, let's call it the current pointer and the previous pointer. Okay. Now the current pointer is used to locate the node, the target node that you want to remove. And the previous pointer is used to reference the predecessor of the current node. Okay, so it is the predecessor, the left-hand side neighbor. Okay. Now when we start the traversal, okay, we start the inspection from the beginning. So current will be starting from head. Okay, and the first node in the linked list does not have a predecessor. Okay, there's no predecessor before the first node. So that's why the initial value of previous is set to null pointer. Okay, because the first node does not have a predecessor. Okay, so whenever you define your variable, you use it to carry out certain tasks, and you want to enforce certain relationship between the two variables. Okay, then your initialization should set up accordingly. Okay, you cannot say, okay, I don't care what is the initial value of previous. No, you need to set it up, okay, properly to preserve their relationship. Okay. Now, initially, the pointer Pires is null pointer. Okay? And current is now pointing to the first node. Okay. Then we want to find whether or not the value x exists in the linked list. If yes, then current, we want to use current to point to the target node and Pires to point to his predecessor. Now the searching can be done with this simple while loop. Okay. Now as long as current is not a null pointer, meaning that current is pointing to a valid node, you need to test this first before you use it to retrieve a data value. Okay, so we make sure, first of all, we make sure that current is not a null pointer. Then we use it to retrieve a data value compared to x. Okay? Now if it is not equal to x, then we continue our traversal. So we move downward. When we move down, okay, the pointer Pires will be updated to current. And current will be updated to point to the next node. Okay, so Pires will move to current, and current will move to length of current. Okay. Now you should not write this pair of statements. If you write it this way, you will have the null pointer exception right away because initially Pires is a null pointer. Okay, because now this is null. Okay, you don't have a length from a null pointer. Okay. So the proper way to write your code, the statement is you assign the value of current to Pires, and then you assign the length of current to current. Okay. Now when your while loop stops, okay, either one of these two conditions will be true. Okay, either current is the null pointer when it stops. Okay, then it means that the value x is not found in the linked list. Okay, so if x is not found in the linked list, you don't need to do anything. Okay, because your intention is to remove x and x does not exist, then you don't need to do anything. Just like I receive an assignment from student with a name. That student name does not exist in my class. Okay, then how can I record the marks? Okay, then I don't need to do anything. Okay, what I'm saying to you is true. The grader tell me that he marking the assignment as one name that is not in the list. I don't know why. Usually in the past, we may encounter cases that student B submit a program with the name of student A. It still makes sense. Okay. But now a student A submit a program with the name of an unknown person. Now, if current is not a null pointer, okay, then the while loop is terminated because you find the value x. Okay? So the implication is that if current is not a null pointer, then the data in the current node must be equal to x. Okay, then you have found it. Okay. Now finding this node, the next step is to remove it. Okay. Now, if you find, okay, the node in this situation, current is now pointing at node 33, and Pires is pointing to his predecessor. Okay. Then to do the removal, you have two possibilities. The first one is Pires is not a null pointer. Okay, so when Pires is not a null pointer, then it means that the node that you try to remove is not the first node in the linked list. Okay? Then to remove this node, you need to modify the length of the Pires node to bypass current and points to his successor. Okay? Then you will update the length of Pires, assign the value to it the length of current. Okay, so you set the pointer of Pires, bypass current, points to his successor. Okay. If Pires is the null pointer, then it means that the node that you're trying to remove is the first node. It doesn't have a predecessor. So if you are removing the first node, then you need to update the value of head, because head is supposed to point to the first node in the linked list. Okay, so in that case, you will update head to point to the second node in the linked list. Now, after this changes to the pointers in the linked list, then you can physically delete the current node and return the memory space to the operating system. So that in the future, if you want to request memory resource, your program can function. Otherwise, if you keep on asking for allocating memory resource and you never return it back to the OS, okay, so sooner or later, you run out of memory resource and your program crashes. Okay, so the programmer need to manage the memory resource. Now you see that in this delete statement, we don't have the bracket, because comparing with some of the example programs. Okay. When we return the memory resource to the operating system, now you see in some of those examples, we have the bracket after the operator delete. Okay, why we have the bracket? Because A is an array. It is not one single record. Okay. When A is created, let's see. Okay. When A is created, it is an array. Okay, so that's why in the delete operator, you need to tell the system that I want to delete the whole array. Okay. Now, in the case of linked list, when you allocate a node, you request for one node. Okay, the memory space for one node. It is not an array of nodes. Okay, so that's why when you delete the node, okay, there's no square bracket after the delete. Okay, you are deleting one node. Now the next example is for the situations where we are going to insert a value to a linked list where the elements in the linked list are maintained in ascending order. So the linked list is ordered. Okay. So in this case, when you do the insertion, you need to find the proper place to add your new node. Now to add a new value x, okay, then the first two steps are quite standard. First of all, you need to create the node. Okay, then you put your value into the newly created node. Okay, afterward, you consider how to put it into your linked list. Now, if your linked list initially is empty, okay, then it means that the head pointer has the null value. Okay, so it's a null pointer. Okay, now, to do the insertion, then you first of all you test if head is null. Okay, if head is null, then you simply put the new node p, okay, at the beginning. Okay, so you set the length of p to head, and then head is updated to p. Okay, now the other situation. Now if you have the, say, a linked list, the first node, the value is 10. Now we want to, okay, insert the value 5. And the numbers in the linked list are supposed to be maintained in ascending order. So in this case, the new node will be put at the front. Okay, so in this case, you will also make the length of p points to head, and then head, okay, points to p. Okay, so the two steps, okay, for the case when the head is null or the insertion is before the first node, okay, the two cases, okay, the handling are the same, so they can be combined into this if statement. Okay, so either head is null, or if head is not null but x is less than or equals to the first element, then you put it, the new node at the front. Okay. Otherwise, okay, then you need to traverse the linked list to determine the point of insertion. Now, if you have a linked list already, have some values, to carry out the insertion. Okay, so once again, okay, we will traverse the linked list with a pair of pointers, current and previous. Okay, so current will find, okay, the node that has a value greater than or equals to x. And when you find it, then the place of insertion will be insert before current. Now if you want to make something before current, you need to know its original predecessor. So that's why we need another pointer, previous. Okay. Now to start the traversal, this time we start from the second node. Okay. So this will be current and previous. Okay. So this will be the initial condition. Why we do this? Because we have already made a comparison with the first node in the linked list. We already know that the value x is greater than the value in the first node. Okay, so we know this condition already. Okay, so that's why we start the comparison from the second node. Okay, so current start from the successor of head, and his predecessor is head. Okay? Then to find the point of insertion, once again you see the same while loop structure. As long as current is not the null pointer, and x is greater than the data value in the current node, then we move forward. Okay? So when it stops, after it stops, the insertion is to put the node P after the node predecessor. Now, when you say have this, okay, length is the last node, say is 40. If you say you insert 65, okay, so when you insert 65, 65 is supposed to be added after the last node. Okay, so when you traverse the length with the pointer variable current and periods, so current will continue to move forward. Okay, now when periods is pointing at the last node and now current is the node pointer. Okay, then your loop stop. Okay, so after this while loop stop execution, the new node will be put after periods. Okay, so putting P after periods will be you set the length of P to the length of periods. Okay, so if you, in this case, you have a new node, value 65, and this is P. So length of P is set to length of periods, so there's nothing borrowed. And now the length of periods will be changed to points to P. Okay. Now then you will set up the pointers properly. And the length is terminated by the null pointer. Now if current is not the null pointer, it doesn't matter because you have something follows. Okay, the inserted node. Now, null pointer exception is a common error. Later on you will encounter this error, and usually programmers hate this error very much because once you have such an error, your program crash. Okay, and then you scratch your head. What has gone wrong? Okay. So it is important that whenever you use a pointer variable in your program, that variable must be properly initialized and it must be tested before you use it. Okay, you make sure that it is not a null value. Now, when we see this symbol, just one remark about some student programs for the second tutorial. Now, if we represent a group of numbers in an array, when we say that we want to remove an element in an array, what we mean is that we are going to take away this number and pack the remaining numbers onto the left hand side. So the result of removing the value 5 will give you the array 3, 7, and 9. Okay, and we need an integer variables to represent the length, the logical length of the array. Okay, so after removing a number, we have this new state in the data structures. Now the array contains 3 numbers at index 0, 1, and 2. Okay, and the value of n is 3. Now, somehow, some students, I don't know why, they have a very serious misconception. To remove the value 5, we simply say A1 assign the null value, then it is removed. Okay, I don't know why some of you have such a concept. Okay, the effect of this statement, simply change the value 5 to 0, nothing else. Okay, so the value will not disappear. Okay, and the value n is not changed. So the content in your group of numbers simply change from 3579 to 3079. So 0 is a weighted value for integer. It is not a so-called invariant value. Okay? Now, so far we have seen some example programs that manipulate a linked list. Okay. Usually, when we design our program, we will put the codes into the form of a function. Now, here we show you some examples of a design of template function. Now, to find the length of a linked list, okay, since the node structure is defined as template. Okay, now the node structure is defined as template. Okay, then the functions to operate on a linked list can also be defined as a template function, such that when you replace the data type by a concrete type, then the function can be used without the programmer doesn't need to do any changes to it. Okay. Now, to put a function as a template, then once again you have the template statement. You're defining this function, okay, with the type parameters. Then within this function, you receive a pointer that points to a node for the generic type. Okay. Then within the function, you define the variable also for the given generic type. Okay. Now the next example is to find the minimum. Okay, in a linked list. Okay, I think I have a typo in the older version of the notes. Okay, if you print it before today, okay, then you may change this from integer to type. Okay, because the variable min should be defined as the generic type. Now to find the minimum, okay, in a linked list, the minimum value, then the precondition is that the list cannot be empty. Okay, if the list is empty, then I don't know how to tell you what is the minimum. Okay, now with this precondition, then first of all I assume the data in the first node is the smallest value, so I save it. Then I start the comparisons from the second node. Okay, so P starts from the length of the first node. Okay, then as long as P is not a null pointer, okay, we compare the value of P with min. Okay, if this is less than min, then min is updated. Okay, after that, P will move on to the next node. When we reach the end of the linked list, okay, we find out the mean. Okay, the mean value, and then we make a return. Well, I think I have another type of this should also be type, not int. Now change this, the returned value of get mean to type, not integer type. Okay, change this to type. Now one more example, then we'll take a break. Now the same kind of operations. Now in this example, okay, we are going to merge two order linked lists. Okay, so we have two linked lists with the data elements sorted in ascending order. Okay, and in the merging, we are supposed to create a new linked list that contains the data elements without changing, okay, the two input lists A and B. So A and B are passed as constant parameter. Okay, so it means that within the function we cannot modify, okay, the linked list A and the linked list B. Okay, so in this merge function we will create a new list contains the elements of A and B, and the resultant list will have the data values arranged in ascending order. Now you have two input, okay, two input linked list A and B. Okay. Now, when we do the merging, okay, we compare we traverse the two linked lists from left to right. Okay. As long as we have two weighted nodes, we compare their value, and then we will copy the smaller data into the result list. Okay. Now when we put the value into the result list, we will append it at the end of the result list. Okay. So we will repeatedly do this operations to add a node to the end of the result list. However, when you are adding something to the end of a result list, you need to first of all, make sure that the result list is not empty, because the steps to handle it will not be the same. Now, if you have a existing node, you put something at the end. Okay, you have a step of a sequence of steps. However, if the result list is initially empty, then your steps will be different. Okay, so since you have these two different situations to consider, it will make your internal loop more complex, because every time you will have to first check if your result list is initially empty or not empty. But it will be empty only for the first time, and the subsequent iteration it will not be empty. Okay, so one way to simplify it, the design of the program statements is that we will create a dummy header node before we start the computation. Okay, so we will first create a dummy header node. Okay, and set a variable R points to that. Okay, dummy header node. And we will traverse the list A and B with two other pointer variables, P and Q. Okay. Then we start to enter into the while loop. Now the merging will be very much unlike the case that we merge two sorted array. Okay, the logic is the same, but the only difference is that now we are dealing with linked list. Okay, so as long as P is not a null pointer and Q is not a null pointer, then we need to compare the data value of the two nodes. Okay, now within the loop, we will extend the result is to the variable R will be pointing to the last node in the result list. Okay, so every time when we extend it, we create a new node, connect it to the last node. Okay, so the effect is that now we create a new node. Okay, and then R will be modified to point to the new node, and after that we copy the smaller data of node P or Q to node R. So if the data in P is less than or equals to the data in Q, we copy the data in P to R, and then P is moved to its successor. Otherwise, we copy the data from Q to R, and then Q is moved to its successor. Okay, so it will be like the processing of an array that we update the index I or j. Okay, so we repeat this loop until one of the two lists is exhausted. Okay, so when we terminate the first while loop, then we copy the remaining data from either P or Q to the list R. Okay, these steps will be the same for the two cases. Okay. Now after all the copying, in the result list, R is now pointing to the last node. Then we need to set the length of the last node to null. To terminate, properly terminate the result list. And after that, now this is only a dummy header node without data. We created simply to use it to simplify the first while loop. So there's no data in the header. So the first node in the result list will be the length of header. Now R is changed to point to the first data node. Now R is updated to point to the first data node. And then we delete the header. We don't leave it further. We return it to the operating system. Afterwards, we return out.
That's second last one. First one.
Now let's put some numbers into the examples. I have to say that I'm always a bit lazy. Don't want to go through every single steps of the examples. Now before we enter into the while loop, we create a header. Okay. And now this is the first iteration. P and Q are not null. We compare the data value. Now the first data should be 5 in the result list. Now there's nothing follow the node R. Okay, so in order to put one value into the result list, first of all we need to create a new node. Okay, so this will be the first step. Creating the new node and point to this new node by the length of R. Okay, and after creating this node, now the value of R is supposed to point to the last node in the result list. Okay, so that's why R is changed to point to the newly created node. After that, we copy the value 5 from P to R. And then P is moved to his successor. And we repeat the process again. Now in the next iteration, we compare 7 with 9. So the data to be copied to the result list is 7. So once again, first we create a new node, extend the result list. Now R will point to the new node and copy the data value 7. And Q is now moved to his successor. Okay, so we repeat this sequence, and the result list will be extend one node at a time. Okay, so let's take a break first, and then we'll continue.
Bom dia.